Well, it's a great pleasure to be able to talk. I've had so much fun at this conference. If for nothing else than to hear Bob Weinberg mention that he had to leave the meeting to deconstruct a beaver dam. I'd like to get to that point in my career when I can end a talk on that kind of note. Yeah, but I'm going to talk today about a tool that we've been working on for a little while here, and it sort of started as a small project, and it's grown into something that we've become pretty proud of. It's called the CNS TAP tool. I'll get into what that means and what it stands for. So I'll just start with this slide, and as I started to dabble in this area of precision medicine, it became, very quickly apparent to me that, and I think to a lot of us who are working in this space, that precision medicine is incredibly subjective, and it feels a little messy. It's actually apparent to the students and medical students who do it with us. They say, so that's it. You and the others on the tumor board just kind of make a decision based on what you know so far, and it lacks a lot of objectivity. And yet we have so many tools. I mean, just the last 2 days of presentations, you realize how much knowledge is out there. And so how can we harness that into being precise and being objective in the therapies that we actually choose? So that's what we've been working on, and I think we're just starting to figure out how to do that. And I would say it's been great to start to get further integrated into PNOC and CBTN, where we'd really like to let this tool grow and develop and become truly objective and precise. So when I finished fellowship back in 2014 and started to take care of brain tumor patients, our clinic, like a lot of other children's hospital, was just sort of hitting the ground running with tumor sequencing and offering it to higher risk patients. We had an in-house platform called MyOncoSeq, which we do this day, which is a CLIA certified research based test, which is DNA and RNA sequencing and germline sequencing. And at the time, Dr. Robertson, Pat Robertson, who's still another neuro-oncologist here, sort of put me in charge of who are we going to offer sequencing to and what are we going to do with that. And Rajan Modi, our lead PI on this study, also really said, brain tumors is a space I need your help with. And for me, with my research interest in high-grade glioma and that patient population really needing something beyond what do we do after radiation, we started sequencing all of our high-grade glioma patients. So the first half of this talk is pretty high-grade glioma oriented, but we are moving outside of that into sort of higher grade tumors in general. So we would get these results from these high-grade patients, and the three of us would brainstorm around a table, and those around the table discussions spread, and we started inviting pharmacists and pathologists and surgeons and researchers. And then this was what our precision medicine, brain tumor precision medicine conference looked like for a while. And then we actually started discussing with outside centers, what would you do with a case like this? And we had at its height, we were having 5, 10, 15 other centers call in when we would have these sort of monthly, every other month conferences to discuss cases. And we learned a ton. We learned a ton from other centers and from each other and from the pharmacists and researchers. We started to have enough patients that we had chosen precision therapies, mostly off trial, that we started to look at our center's experience with that. And this was just our first cohort of 50 high-grade brain tumor patients that we sequenced and what we did with the information. And what we found was that it was our high-grade glial tumors, or just glial tumors in general, where we were more likely to do something with the sequencing results. As many, in our case, as 70%. And mostly these were patients that were, didn't have a good option other than radiation, or if we could find them a clinical trial. So that was perhaps why we moved so quickly, but also just because we had targets to go after. And we published a handful of papers about this, but we've tried a lot of different drugs. And you see here, primarily at the start, these were drugs in isolation, but in the later years and more recently, it's drugs in combination. And we wanted to start to make this process a little bit more objective. This still, even with the precision medicine tumor board, it felt subjective. It felt like, you know, whoever was there that day might lean you towards a drug that they'd had a good experience with, but was that the right decision for that patient? And how do we study efficacy in such a heterogeneous cohort, getting heterogeneous drugs in a heterogeneously chosen process, even with the best, you know, best intentions? And so one of the next things we did was to say, okay, we're not the only center sequencing. What is going on across other centers? And around 2017, 2018, our center and 3 other centers published papers with just basically that, their first cohort of sequencing gliomas and what they did with that information. And what we did was we sort of integrated that into a review where we looked at what was the consensus across these centers? How often was sequencing feasible, useful? How often did it lead to a precision therapy or a change in diagnosis? But also just really nuts and bolts things like what were the genes in the gene panels across the centers? And do you really need a 1700 gene panel? Do you need whole exome when it just comes down to being able to offer precision medicine advice? And so, you know, when it came down to it, it's when you start doing precision medicine work, it feels like there's an infinite choice of drugs that you could come across. In fact, there are new drugs coming out on a regular basis, but in the end, it does come down to very small number of pathways that you're targeting. And probably, if you look at tumor boards at these centers and other centers that have and some of these newer PNOC trials with precision medicine, it is not an infinite number of drugs. It's probably more like 20 to 30, at most 40 to 50 drugs targeting about 10 to 12 pathways. And so how could we make the our understanding of these which drugs to use more objective? So these were the areas that really felt like we needed improvement. And we kind of felt these themselves, but oftentimes it was students or pharmacists that attended these meetings who said, yeah, still doesn't feel objective or quantifiable or studyable. So we needed to standardize this. We clearly, our talks for these brain tumors hovered around blood-brain barrier penetration and how do we predict which drugs would cross well. What about, as we started to move into combinatorial selections, how do we compare drugs across classes? And I think what we were trying to do was to say, this is what we might do for our tumor board, but also how would we do it in future trials? And what if you're just a clinician at a non-major children's hospitals and you just wanted to know what to do with those sequencing results if you were going to try something off trial? How would you score these drugs and make decisions? Integrating the literature and research at all, let alone in real time, is daunting. You know, if you look at these classes of drugs, how do you compare the quality of the literature and what's out there, and how do you keep up with it? And then when you start to look at patient-specific values, how do you take into account things like clonality, and how do you compare a fusion versus an amplification? This is where precision medicine starts to get really messy, and decisions are made that, you know, do feel subjective. And we wanted to make this whole process, however we were going to sort through all this, not incredibly time burdensome. So how could we get through this data in a way that we would, those of us that all had other jobs, all, you know, working on other research projects or clinical projects, could do this and keep up with this data and in a feasible way. So this is the group that's grown over the years. It started with Bernie, who is a sort of brilliant leukemia pharmacist, and really kind of boiled down CNS penetration for us in a way that continues to speak to me and to anybody who is in this space and talks with him. And then others have joined the group. Andrea Flynn, who a lot of you have met through PNOC Precision Medicine Tumor Boards, who's on faculty here as a neuro-oncologist. We have a ton of really bright and motivated students. And then other pharmacists and health infrastructure and learning faculty who have been a part of this process. So when we what we started to do was we took our precision medicine conferences and we tried to boil it down into what were the things that we discussed that might be able to be quantifiable. So if you looked at what was in the literature for the targets and the drugs, a lot of it came down to what was available on in vitro data, in vivo data, and then you move into clinical data where a brain tumor is targeted, safety data, especially as it related to pediatric patients. Did you have pediatric safety data? And then this is a big one for us. It kept coming up in our conferences. Which of those drugs is going to get in? As we know, a lot of these targeted drugs have failed because they didn't get in. And our system was pretty straightforward, but we haven't been able to do better than this, which was, what's our best estimate of how much of that, what is the IC50 of that drug for that target? And what's our best estimate of how much that drug gets into the brain? And is it better? I mean, it's just as simple as +1, 0, or -1. And then some logistical things, FDA approval. And then we get into patient-specific things like dominant variant, tier of mutation, and whether there's an available relevant clinical trial. Because we did want to boil this all down, but then encourage patients to get onto clinical trials. So we published this. This was our first pass, and it was really just sort of based on, if we were to put a weight to all of these things, based on when humans, our best metrics, our neuro-oncologists and our people doing precision medicine boards were coming up with, how would we make that objective so that we could tweak the system over time? And these are the weightings that came up and the ranges of points. And it gave us something that we could start to score. So again, here's our first cohort of patients that we've treated. And this was our best, this is still to this day one of our better ways of visualizing this, which is on the x-axis, the drugs themselves and they're just their baseline score from what we could find in the literature. And then on the y-axis is how many times did our tumor board recommend it, and we just sort of would keep that up to date, and just to kind of spread out the drugs and sort of keep us aware of what we've used. So when we looked retrospectively using the tool and the drugs that we had chosen in the board, it did coincide 85% of the time, and that's not too surprising. We tweaked this tool to coincide. So this was the best we could do with the tool to coincide with our own experience. And then we worked with the Colorado group who was doing things in their own tumor board, and our tool was concordant with their decisions about 50% of the time. The next version of this tool that we've been working on more recently is an online-based version of this tool. And this is really the work of an incredibly gifted undergraduate student who will be applying to MD PhD student in the coming year. And if any of you come across his application, you need to grab him up. He has gotten funding for this project. He has pulled together computer programmers and faculty to organize this, and he really drives the ship on pushing this tool into now what is a usable link. And so I'm going to try to click out to this and see if I don't lose you guys. Are you guys able to see my Chrome browser now? I hope so. Yep. Okay, great. All right, so this is live. You guys are welcome to go to this website after the meeting, cnstap.org, and it'll basically takes our tool and puts it online. There's tutorials that you can use as you, if you're new to it. There's a website, or there's a user manual, website tutorial, as well as a YouTube video that Karthik made. But if you don't need that, I'll just do a quick generation of a report. So these are the various pathways that you might get on your patient. So we'll pick a couple of those pathways and drugs that you might be considering. This is their baseline scores. There are things you can toggle up on the tab, like we want to make one of those pathway graphs to visualize what this will look like. And we want to enter in some patient data information. And I won't get you into the details. There is pop-out visualizations if you want to say, what is this category? So for these patients categories, we say clonality, and you can say that's either a dominant or less than dominant, or is it a fusion, which gives it a higher score. What about the tier of this? And this is something that has been discussed in some of the others. Is this a variant that you have in this pathway that is known to be clinically targetable, a tier 2 or tier 1? And you can look at this link for a website or a spreadsheet of which genes have that tier status. And then this one, if you want to say, are there clinical trials for those drugs which might raise the value of that, you can this brings you to clinicaltrials.gov. So we put in these patient-specific values, and then what we do is we there's a note space. You can, if you have any notes you want to enter into the, for example, when we generate these reports, we sometimes will add some of our own sort of additional information, recommend no temozolomide for this patient, and then we just generate a report. And this is the PDF that comes out. And you see down here, you'll see the various drugs is probably very small for those of you who can't see, but all the drugs that you might consider, their scores on this y-axis now, and then the open circle is patient-specific information. And this might allow you as a clinician to start to look across categories and classes as to what drugs you might want to choose, and just start to add some objectivity to some of these decisions that we're making. Let me go back to my talk here. So we've been doing this. As we entered PNOC a couple of years ago, or a year ago, I don't know when it was, we got wind of the precision medicine trials and looked backwards at the PNOC 03, which was closing. And you guys have been sort of familiar with this, but this was in brainstem patients, and this was recently published. But then as this PNOC 008 in non-brainstem patients was ongoing, the PIs of this trial asked if we could somehow integrate CNS TAP into this, which was an ongoing prospective precision medicine tumor board-based trial. And the way that we've decided to do this with them is really to study how much the tool affects decision-making. So the tumor board will make these decisions, they'll come up with a treatment plan, and then we'll show them our CNS TAP report for that patient, and then they can decide if they want to change those. And so right now we're just studying, did the tool affect decision-making when it was presented to you in real time? Future trials might actually just use the tool to choose drugs. Future things that we've looked at to improve the objectivity of this tool further. So, what our pharmacists have taught us is that some of this prediction of blood-brain barrier penetration is not as random as you might think. And some of you have maybe seen this boiled egg tool that came out of this group in Switzerland, where it actually uses just the Lipinski rules of drug size and lipophilicity and polarity to predict the likelihood that drugs will cross the blood-brain barrier. The boiled egg, the magic spot is in the yolk here, and you see all our drugs here. Very few of them are actually in that sweet spot. Other things we're working at locally with the lab here who has a humanized Drosophila blood-brain barrier for high throughput screening of drugs that might be effluxed. We are working with them to identify compounds that are clinically relevant. And then I think a big thing for us is, at best, our tool is only as good as the data that comes into it, right? And it still feels a little bit clunky in the fact that we're pulling data from various case reports or larger series or mouse data that's good, that's bad. And what we'd really like to do is to make it purely one system. You put all the drugs in mice in a very similar fashion, and you just get a true brain penetration. You could do it with or without a tumor and see what you get, and just have a very consistent score that we could feed into this tool to be very objective about it. We've done it with 10 drugs so far. It's expensive, so we are fundraising. And then starting to work outside of high-grade glioma with the folks in the medulla working groups to start to build in vitro screens and in vivo screens that are objective, looking at a pathway. You might have group 3 medullo. How does that do with these drugs? Maybe that's what we use for our IC50 across the whole platform rather than the various literature. Things that we are working right now to further integrate with PNOC and CBTN. And, we had this sort of fork in the road probably about 3 months ago, where we said, what do we do with this tool? It's online now. We could potentially consider giving this to industry, to Foundation Medicine. We could consider keeping it at U of M. And I think we all loved what is going on at CBTN and PNOC. And we just said, let's throw this tool, and however we can integrate it further and let it grow in this space where you have all these people who kind of share this principle of improving objectivity, improving therapies for children with brain tumors. Let's just keep it in that space. So we're doing our best, and we had a really exciting first call with Adam and folks at CBTN, and we're going to now make this a monthly call to build in precision medicine optimization and integration of this tool. So the first meeting is June 17th at 3 p.m. Eastern, and it's going to be the third Thursday of every month. If you are interested in joining, email me. We want to bring in more people, pharmacists, researchers, oncologists, data scientists, anybody who thinks that they might be interested in integrating this. We had a lot of cool brainstormed ideas. Ken Cohen has this idea of therapeutic or tumor profile neighborhoods, and how we might use the data that's already in the CBTN and the CNS TAP tool to decipher these neighborhoods. As we talked about improving the drug screens. And then immediately at that first meeting, there were ideas for how we could get this thing funded at the national level. Adam had some great ideas. Rob had some great ideas for grants that could come out of this. And then, just building off of all of the amazing things that Adam just talked about, we need to tie this together to CNS TAP, and I think we're all excited to do that. And so, I think the sky is the limit for how we might be able to make this precision medicine more objective. So I will end there. I don't know if I'm ahead or behind schedule, but I know that generally we're behind schedule. So I understand if there's not time for questions, but feel free to email me or chat me. I'm happy to answer questions about the tool. Appreciate the time.